Welcome to episode 5 of Audio Guide to the Galaxies Season 2, a podcast put together by those of us at Scitech to help you keep connected with our wonderful night sky. My name is Leah, one of the presenters in the Scitech Planetarium, and tonight we will be expanding our horizons, going beyond the individual stars we see in the night sky to get a look at the bigger picture. Tonight we will be focusing on the Milky Way and looking towards the constellation of Sagittarius to discover what is hidden there in the depths. This recording is timed to take place at 7 p.m. on any night of the week starting the 26th of June. So if the weather isn't looking too great, don't worry. You will be able to listen to this whenever it suits best. In fact, if you are heading out camping anytime soon, then this is a great episode to listen to, as some of the objects we are finding tonight are better viewed in darker skies with a little light pollution. As always though, it can get cold while stargazing, so please make sure you are rugged up and nice and warm before heading out. Now that we're all ready, let's begin. It's always fun to spot our favourite objects in the sky, pointing out planets, stars, constellations, and whatever else we have the opportunity to see. Even though the countless stars shining bright overhead appear to be randomly scattered across the sky, they have served a purpose to us. Using these stars, piece by piece, we have mapped out constellations in the sky, allowing us to navigate our way around the cosmos. And yet all of these stars belong to something far greater, an object of immense importance, even though you may not realize it. Together, they form a galaxy that we call the Milky Way, our home in the universe. Each and every star that you see in the sky is part of our home galaxy. It can be easy for me to say the word galaxy, but it can be even more difficult to imagine what exactly a galaxy is. The simple answer is a great big collection of stars that are held together by gravity and moving through space together. In the case of the Milky Way, it is a collection of nearly 400 billion stars, although we can't see them all here from Earth. And the galaxy itself is pretty big too. The Milky Way stretches 200,000 light years across. Light can reach the moon in 1 second. But the Milky Way is so big that it would take 200,000 years to travel from one side of the Milky Way to the other. To give you an idea of just how big that is, have a look at your pinky. If the width of your pinky was the size of our solar system, then the Milky Way would be the size of Australia. Now, you may have seen pictures of galaxies before and think that our galaxy looks nothing like them. But that's not true. The Milky Way actually looks very similar to all the other galaxies in the universe. You see, the reason why it looks so different to us is because we are looking at the Milky Way from the inside rather than the outside. So our view from Earth shows us stars all around us, spread out in a rather disorganized way. Yet, despite this random chaos, we can see a hint of the galaxy's structure by looking at the part of the Milky Way in the sky that is the most popular. That band of fuzzy light that arches across the sky from one side to the other. When you stargaze from your backyard, you can't see this faint band of light. That's because all of the surrounding lights from our homes, other people's homes, streetlights, cars driving by, all this bright light can block out the fainter light in the sky, creating something that we call light pollution. But WA, and Australia in general, is quite a special place. Our population is so spread out that there are many places that you can go to get away from light pollution. And if you enjoy camping, you'll know there are many opportunities in WA to spot that band of light in the sky. If you're camping right now, or far away from bright lights, you may be able to spot it already. But if you can't see it, or still have a bit of light pollution around, I can show you where to look. The band of light, commonly known as the Milky Way, stretches across the southern sky from the east to west in a shape similar to a rainbow. And once again, our constellations come to the rescue to help us map out this galactic rainbow across the sky. The constellation that I want you to find is the Southern Cross, currently sitting very high in the southern sky. Remember, if you're having a little trouble finding it, use the pointers to guide your way. The position of the Southern Cross marks the peak of the arch, the highest point of our galactic rainbow. To the right, the band of light extends downwards towards the west, passing through the constellations Carina and Puppis, the constellations we know make up part of the great ship Argo. The band of light finishes low in the western sky, marked out by the constellation of Canis Major and the bright star of Sirius. To the left of the Southern Cross, the rest of our galactic rainbow arches down to the east. The faint band of light passes through the pointers and heads down towards the tail of the great scorpion Scorpius. The arch continues to extend down to the horizon, finishing directly east. It is along this path that you can find that magnificent band of light, and even if you can't quite see it because of light pollution, what you might notice is that there are actually many, many more stars along this region of the sky. The reason why we get this exceptional view and why there are so many stars along this direction is all down to the shape of the galaxy. It may not seem obvious, but this arch of faint light and stars is actually showing us the shape of our galaxy. If you were to view the Milky Way from the outside, it would look like a flat, round disc, a little bit like the shape of a pancake, or a pancake made of stars. This means that if you were looking at the Milky Way from the side, you will find most of the stars of the galaxy along a straight line, just like if you were to look at a pancake from the side. What about if you were inside that pancake of stars? Let's say halfway between the edge and the center. What would it look like then? Well, if we looked towards the center of our flat galactic pancake, we would see most of the stars that make up the galaxy, arranged in a straight line arching in front of you. And there are hundreds of billions of stars in this direction. So it reaches a point where you can't see each individual star anymore. Instead, it becomes this blended concoction of starlight. Well, when we look up to the southern sky, that is exactly what we're seeing. That faint band of light is the light coming from countless billions of stars, all arranged in a flat, round disc. Remember though, our pancake of stars is still fairly thick, so it means that we can still see stars in every direction we look. But there are far more towards the direction of the center because we are looking at a greater area of the galaxy. Now, at the risk of making myself even more hungry for pancakes, there is one more similarity between pancakes and galaxies. We know that pancakes are made from many different ingredients like flour, milk, and eggs. Well, a galaxy is also made up of many different ingredients. A galaxy is actually a mixture of stars, dust, and gas, all orbiting around the center. You can spot great immense gas clouds in the heart of stellar nurseries and supernova remnants, where there is so much energy that the gas is lit up, making it easy enough to see. Dust, on the other hand, can be difficult to spot, as it doesn't shine bright when given enough energy. But this means it's good at blocking out starlight. If you look along the faint band of light arching in the sky, you might notice darker patches. Those dark patches are thanks to the dust clouds between us and the stars. As the light from those stars heads towards us, the light gets absorbed by the dust, meaning we never get to see that starlight. It does make for a beautiful view in the night sky though. Most other galaxies in the universe are pretty far away. In fact, our nearest neighbour, the Andromeda Galaxy, is 2.5 million light years away. If you thought distances in the galaxy were big, the universe is even bigger. However, this means that we can't really spot many galaxies with just our eyes. Here in the southern hemisphere, we are a little bit lucky though, because there are actually 2 dwarf galaxies currently orbiting around the Milky Way that are close enough for us to see. They are the Large Magellanic Cloud and the Small Magellanic Cloud. You can spot them both in the southern sky, looking like little fuzzy patches. You do need to be far away from light pollution though in order to see them, so remember to look for these the next time you go camping. To find the Large Magellanic Cloud, or LMC, start at the point halfway between the 2 pointer stars Alpha and Beta Centauri. From this middle point, draw a line straight out into the sky, sideways to the line joining the pointers and in the direction of the horizon. You'll find the LMC along the direction of this line, roughly 1 handspan above the horizon. The LMC will just look like a fuzzy patch of light in the sky that is a little bit bigger than your thumb. This dwarf galaxy lies 158,000 light years away and is around 7 times smaller than the Milky Way. To find the Small Magellanic Cloud, or SMC, start with the topmost star of the Southern Cross. Draw a line down through the long axis towards the bottommost star. Keep that line going towards the horizon. Along the direction of that line, roughly 4 finger widths above the horizon, you should see a small little fuzzy patch. This is the SMC, sitting 199,000 light years away and 14 times smaller than the Milky Way. These 2 faint objects are beyond our very own galaxy, and remarkably, some of the most distant things you can spot with your eyes. The LMC and SMC are a special treat for those of us in the Southern Hemisphere. But we are in luck because that is not the only treat. Here in the Southern Hemisphere, we also have the opportunity of seeing the heart of our Milky Way. Due to the tilt of the Earth here in the Southern Hemisphere, we are facing towards the galactic center, meaning it can rise up high in our skies during winter, providing us with amazing views. To spot the center of the Milky Way, you need to find the constellation of Sagittarius. Tonight we can find Sagittarius low in the eastern sky, near the constellation of Scorpius, one we learnt about a few weeks ago. Look towards the eastern sky and trace out the scorpion, finishing off with the curl of its tail. Sagittarius lies directly below Shaula, the star that marks the tip of the scorpion's tail, and it covers roughly a handspan and a half of the sky. Thanks to the fact that we are staring towards the direct center of the galaxy, you can see there are many stars throughout this constellation, and it can be a little difficult to make out the picture it represents. I'll give you a hint though, it is the same creature that we came across back in episode 1. A centaur, the mythological being that was half human, half horse. Unlike the wise and gentle centaur depicted in the constellation of Centaurus, this centaur is often thought of as a warrior, with weapons in arm and constantly on the attack. Currently in our sky, the centaur is sideways, with its tail touching the horizon and its human body facing up towards the sharp tail of Scorpius. It is also holding its bow and arrow towards the front, ready for an attack at any moment. Do you see it? I'll admit, it is a little more difficult to recognise, but there are actually a few different pictures seen within the constellation of Sagittarius. For example, have you ever heard of the teapot? People can often see a teapot hidden within the fighting centaur, so let's see if we can too. First, start with the star Shawla, the stinger of the scorpion. From Shawla, draw a line straight down towards the direction of the horizon for approximately 4 finger widths. Here, you should see the brightest star of Sagittarius, Cors Australis. The name means the southern part of the bow, but for us, well, it's going to be the southern part of the teapot. If you keep drawing your line from Cors Australis down to the horizon for another 4 finger widths, you will spot another fainter star whose name is Acela. The line between Cors Australis and Acela marks the base of the teapot. And as you can see, just like the centaur, our teapot is also on its side. To find the top of the teapot, start halfway between our base stars and draw a line towards the left for another 3 finger widths. Here you should see the star Cors Borealis, and if you know your Latin, you'll know this means the northern part of the bow. Now the lid of the teapot can be found by making a triangle with Cors Borealis and 2 stars that are just a thumb width to the right of it. The topmost star is Cors Medea, and the bottommost star goes by the name of Namel Sidara. These 2 stars also join with our base stars, Cors Australis and Acela, to show the body of the teapot. From here, you should see 2 stars near Namel Sidara 1 and Acela that trace out the handle of the teapot. And that means the spout can be found in the opposite direction, highlighted by a single star just above Cors Medea, a star called Al-Nasl. Its name means point, which I think works well for both a teapot and a bow and arrow. Now putting that all together, we have ourselves a teapot. It's always interesting to see what pictures you can make out of the stars. Now that we are a little more acquainted with the constellation of Sagittarius, it is time for us to spot something very special, the exact center of our Milky Way galaxy. To find it, we will use 2 stars from our teapot. To find them again, look at the body of the teapot. 2 stars make up the top of the body, and 2 stars make up the base. Acela is the star closest to the horizon that shows the base of the teapot, and Cors Medea is the star furthest from the horizon that shows the top of the teapot. Now, using your finger, draw a line from Acela up towards Cors Medea. Following the direction of this line, draw onwards for another 3 finger widths and stop right there. Take note of that position. If you're worried you have the wrong spot because you can't see anything, don't be worried. Unfortunately, looking towards the direct center of the galaxy, there aren't any notable objects flashing bright for us to spot, even if we got away from all the light pollution. But there is something there, something that even the most powerful telescopes can't see. Do you know what lies at the center of our galaxy? At the center of our galaxy is a black hole, but not just any old black hole. It is a supermassive black hole. The one at the center of the Milky Way goes by the name of Sagittarius A star, and its mass is 4.5 million times greater than our Sun. And I should say, the star in its name is not because it is a star, but because it's spelled with an asterisk. Black holes are powerful objects with so much gravity that no object can escape its pull. Luckily for us though, Sagittarius A star is 26 1,000 light years away, so we don't have to worry about it too much. The interesting thing is that we can't see or detect black holes because they don't give off any light. Their gravity is so strong that not even light can escape them, making them almost invisible. So you may wonder, how do we know that a supermassive black hole is actually there? Well, there are some telltale signs. For example, astronomers have managed to observe stars orbiting at very high speeds around the position of Sagittarius A star. And the best explanation for their strange orbits is the presence of an object with incredible mass, such as a black hole. Another piece of evidence is by looking at that area of the sky in different wavelengths of light, beyond the light that we can see with our eyes. Light such as radio waves and gamma rays show astronomers that a powerful and immense object sits there in the darkness, giving off a lot of energy. An object such as a black hole. In fact, in 2017, a team of astronomers all around the world joined their radio telescopes together to make the Event Horizon Telescope, with the aim of producing the first ever image of a black hole. While it is difficult to see the black hole itself, they were hoping to capture the thin ring of light surrounding the black hole, a ring that is full of material about to be eaten up by the black hole, a little bit like when water drains down a sink. They aimed the telescope at two supermassive black holes, Sagittarius A star and one that sits in the center of a galaxy called M87 that is 50 million light years away. As true Imagineers, they were successful and last year released the first ever image of a black hole, and it looked exactly as scientists had predicted. It was a groundbreaking moment, and if you haven't seen it yet, I definitely recommend taking a look. On the topic of black holes, that does bring us to the end of another episode of Audio Guide to the Galaxy. Tonight we got to gaze out to see the structure of our home galaxy, the Milky Way, and even peer into the depths of Sagittarius to find a supermassive black hole lurking in the heart of our galaxy. Together, we have gotten a greater understanding of all the pieces within our little corner of the universe. And just like the many stars joining together to form a galaxy, each of these pieces join together like a puzzle to form something truly amazing. From galaxies to black holes to stars to planets to moons and even yourself, we are all part of this universe together. Good night, everyone, and remember, you can find the universe just outside.